It is day 8 of Advent of Code, and the haunted wasteland is haunting me. I'm gonna explain to you what I have done. Also, you should have seen on this on the channel a second video about this. This is gonna be the main video where I just talk through it. In the first video, you will see me succeed in the first part, but then absolutely and miserably fail in the second part. And I'm talking through now what happened, and I have a solution now. I've done a time of like, I got some hints by people and stuff. I'm gonna explain what happened and how to solve this, and ultimately what I've learned from this. Okay, and you're gonna see my OBS really quickly because I forgot. Hello. I forgot to test if the microphone is working or not. So, now, oh, you don't see my OBS. Of course you don't, because I'm in full screen. Oh, that is very sweet. But now, we're gonna get to challenge. Day number 8. Haunted Wasted. And I have actually read the beginning parts. You know what I talked about, it being all fluff and stuff. It actually explains what these rings are. I was always like, oh, it looks like a map. It's just a bit odd. Like different regions, like snow and land and desert, I could definitely recognize. So I actually read all the parts, and yes, we are on the snow. Like we're in space, and there's a snow island. We're trying to fix the snow, and we went to the island. Clever. And then we went to the desert island, and we just keep crawling up trying to figure out what's happening with the snow. If I'm still understanding this right, I still didn't 100% read it, but good enough this time. So, you're still riding a camel across Desert Island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. To be fair, she has just finished warning you about ghosts a few minutes ago. Oh, how convenient. One of the camel's pouches is labeled maps. Sure enough, it's full of documents, your puzzle input, about how to navigate the desert. At least you're pretty sure that's what they are. One of the documents contains a list of left-right instructions, and the rest of the documents seem to describe some kind of network of labeled nodes. At least that's what you think they are. I'm going to push this a tiny bit forward. It seems like you're meant to use the left-right instructions to navigate the network. I love these terms because you know in part 2 it's gonna be different. Perhaps if you have the camera follow the instructions, you can escape the haunted wasteland. After examining the maps for a bit, 2 nodes stick out: AAA and ZZZ. You feel like AAA is where you are now, and you have to follow the left-right instructions until you reach ZZZ. This format defines each node of the network individually. For example, and this is our example inputs. Now, I'm gonna talk this. No, I'm gonna keep reading. So we have RL up here, and then we have the individual instructions. Starting with AAA, you need to look up the next element based on the next left-right instruction. So up here we have RL. So we need to first go right, then we need to go left. Now, if the instructions stop, we keep repeating them until we find the solution. So we are at AAA, so we go right. We go to CCC, which is says right here. Then we go left from CCC, which is ZZZ. Boom. So we did it in 2 steps. Of course, you might not find CCC right straight away. If you run out of left-right instructions, repeat the whole sequence of instructions as necessary. RL really means RL, 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 and so on. For this example here is a situation that takes 6 steps to reach ZZZ. Because we have left, left, right, we are at A, we go to B, from B we go to A, from A we go to B, from B we go to A, from A go to B, from B we go to Z. Okay, I hope you got that. Starting at AA, follow the left-right instructions, how many steps are required to reach ZZZ, and that was 21,409. So, what is my solution? By the way, here is the puzzle input, tons of our lefts and rights. And then we have about 798 instructions that are left and rights, like where to go from where. Okay, so I have this again split up into like step 1 and step 2 because step 2 is so massive difference, and also a general solution. And I'm gonna show all of this in just a second. So in our main, as usual, we do a test, we get a file, we do the solution. The test has 2 test inputs because we have different things here for each test input. And the solutions each time is 6. We test the solutions here, and if it all works, then it works, which is amazing, and it does gives us a solution for main. So we get our data and we have our lines as per usual, and then I create my instructions here. Okay, INS for instructions, and what I'm here saying, and as you see, I have started to practice list comprehension, because that was one of the earlier days. That was something that I took away. I need to get better at list comprehension, so I'm actively improving at list comprehension right now. That is a key thing. So what's happening? 4C in LL. But only the first one. Okay, so this very first line, the left and rights, which means if it's one line, that means I have characters that I'm going through. So for each character, I say this part. And we're saying this: give me 0 if C is left, otherwise give me 1. Cool. So left is 0, right is 1. Perfect. So now we have an array of 0s and 1s. And that makes it easier for further down. That's all it is. And then I have instruction 2. That makes some stuff easy as well. So I'm going to use instructions 2 to loop back through my instructions. And I'm going to show you exactly how. So, these were my notes, by the way, for during the challenge, trying to figure this out. If you want to figure out, like, see what my thought process was, please go check out that video. I actually thought I had a general solution, as you'll also see now, but like, I really had to work for a general solution, and it still wasn't good enough. So please check out that video if you're interested. But the idea is, we have the array with 1, 2, 3, 4, and 5, and so on, okay? We have that array. And then as we go through each element, I want to take it out so that it doesn't exist anymore. So what I do, I just pop it at the back of this array. Okay, so 1 doesn't exist anymore here. Oh, what's happening? Yes, there we go. Now we have 2 over here. So now say I take that out and put it in this one. And in that way, I can like rotate around both arrays and make sure, hey, I always have a fresh one, fresh here. Is it the best way? Maybe not. But I could have also just done an index. Now thinking about it, I could have just had a pointer. That would have been better. That would have been better to just have a pointer. Well, c'est la vie. So, and then I have my directions that I'm initializing. So what's happening now? I'm going through, I'm just mapping now. I'm now at the mapping stage. I'm going through each line, starting with the second line now, with the third line. So 0, 1, 2. So starting with the third line, yeah. And I want to parse this into a directions map. So I split it by this symbol, and that way I have, hey, what am I looking for? That's going to be the key. And then those 2 values are going to be my 2 values, left and right, 0 and 1. Okay, so the key is direction 0. Okay, directions of direction 0. And then I'm going to put in it, I first need to strip the 2 brackets away, and then I split it by the comma, and then I get left and I get right. Of directions 1, obviously, everything that's on the right side. And that's it. And that's how I'm creating my array over here. Print directions, boom. You should see an array with the address, and then left and right in arrays. And then here, furthermore, in our dictionary is another address, and then where do we go left and right? So that's what we do. That's now all the prep work done. Now, a little bit more prep work. Now we want to go for our actual step count. How many steps does it take? We have our current, we're starting at AAA, and our target is ZZZ. While the current is not the target, we keep doing the same thing over and over again. So, what are we doing? We are popping out from the beginning of insert I. Again, this is where I could have probably done just a pointer. Definitely should have done a pointer reflecting back, but that is okay. I'm doing it in this weird loop. So it's our elements, our insert elements, and then we'll say current is now directions of current, which is AAA, and then whether I is either left or right, 0 or 1. And then we're gonna have a new current, and that's the loop. Now we increase steps. We insert I into insert. If the length of insert is 0, then insert is insert 2. Or not instruction, sorry. Not insert, instruction. There's so much stuff. Just have a pointer. Okay? You know what? I'm gonna do the pointer right now. Right now, for you, I'm going to have a pointer. Here. Ins point equals 0. Okay? And instead of saying I is ins of ins point, and I'm gonna also say modulo the length of insert. Why am I doing this? And that way I don't have to reset ins point. That makes this, I mean, there's more calculations, but not really. And I can take all of that out and say ins point plus equals 1. Ta-da. That should still work now. Bum, same solution. Who knew? Who knew that this would be so much easier? Okay, that is, yeah. And this happens again. So we have our current address, which literally go into directions, our directions map. We take left or right depending on what our current instruction is. Put it into current, and we go again and take it, and we go again and take it until our current is our target, and then we return the steps. Now, that was easy. That was easy. Part 2. The sandstorm is upon you, and you aren't any closer to escaping the wasteland. You had the camera follow the instructions, but you are barely left your starting position. It's going to take significantly more steps to escape. What if the map isn't for people? What if the map is for ghosts? More assumptions. Are ghosts even bound by the laws of space-time? Only one way to find out. After examining the map, it's the worst way to find out, by the way. After examining the maps a little bit longer, your attention is drawn to a curious fact. The number of nodes with the name ending in A is equal to the number of ending in Z. No. If you were a ghost, you probably just start at every node and start at every node with A and follow all the paths at the same time until they all simultaneously end up at nodes that start with Z. Because why would we wait? Why would we wait for the other ghosts? I'm just teasing. This is just hilarious. So we have a new example, and the solution is going to be 6 again, and it's just going through all of them at the same time. And the point is that at the very end, the same time, both ghosts that start at 11A and 22A need to end up at 11Z and 22Z. Because here they reach them, but at different times. So it really doesn't count. And you can already get a hint here at what's going on in this puzzle. Because this, let's see, that's now millions. So this is trillions. So 21 quadrillion, 165 trillion, 830 million, 176,000 and 7,009 steps was for mine. This takes a really long time. Okay, and so I noticed during my thing. I still brute forced it. Hey, maybe it works. Maybe it works, right? It's, brute force can be a first step, as long as you don't stop there, right? It's always good at least to consider brute forcing, and sometimes to get it in order for you to get more ideas and see what kind of issues you have. Sometimes you can just do that. So now my solution is obviously now going to be slightly different. I did start to brute force because I actually have a solution here now. But what you will notice here is I have a return journal solution attempt that's already optimized. But I just tried it, have all of them do it at the same time. Instead of having a single current, I have a ghost current. I had an array, I think, or still a map. I'm not sure. But G cur stands for ghost current. And just brute forced it. And obviously that didn't give me an answer. Now, here is what my assumption was. And what I needed to do better to make it work, okay? So take all of this away. My wrong assumption was that we have a complex map of points. Like, I assumed a very general case. Oh, that's literally didn't go anywhere. Oh my goodness. My straight lines. That these, for example, connect. Then these are obviously each connect to 2, right? So that these connect to 1 in, 2 out. That these connect. So there's like a complicated network. And that I'm somehow traversing through all of this, right? So that's just that I now need to check from here. Okay, now they all go to all these different places and like that. Okay, so I made this assumption, okay? And this didn't work. And then I sticked with this assumption without checking. And I came up with this solution, thinking, hey, I looked at the input data, and I noticed there's not a lot that end in Z. Actually, there is only 6 or 8 or something like this in my example, and most of the others don't actually. So I thought path compression. I thought, hey, let's say this Z. I also assume that AAZ leads to multiple difference, like BBZ, right? And then Z, and then XYZ, that they are all somehow connected to. That assumption was wrong. This Z only leads to itself. I'll show you. You'll see in a tiny bit how I found that out. But I did assume, hey, this Z will at some point lead to some type of other Z. I am not interested in any of the steps in between. That's what I thought. So I'm gonna calculate this from this Z to this Z once. Okay. Now here is a very interesting thing. Our instructions are 271 characters long, which means depending on where in this phase we are, the path will be completely different. So my general solution, the idea was, hey, it's not enough to know that this is going to take me 5 steps. No, it takes me 5 steps if I'm currently at offset 0 of our phase. If I'm at offset 1, it might take me 300 steps. If I'm at offset 2, it might take me 57 steps. If I'm at offset 3, it might take me 62 steps. And that is okay. So I actually went and said, hey, starting at this set and starting at this offset of the instruction, how many steps does it take me to reach any other Z? And I mapped all of them possibilities for all of the Zs and all of the instructions. Now, that takes like a second or 2 every time. But it's not horribly long. It's not absolutely horrible. And part of the solution I kept because I've worked so hard for it. But my hope was, now that I have all of this, I can now stop skipping between every single step and just jump right there. And you know what? That saved me an average about 10,000 steps. That's not bad. I was impressed. Like, my solution is about 10,000 times faster in average. That is good. It wasn't good enough. It was absolutely not good enough because it still took forever. And that's when you will see in the video me being completely and utterly defeated. What you will also see in the video is me talking, and I didn't find the word for it. I had the concept of in my mind, but I didn't know the word for it. I was talking about two other things. About the lowest common multiplier and about the greatest common divisor. Okay. Obviously, the greatest common divisor is here not a help, but the lowest common multiplier is a help if a very specific case happens. So I had a very quick look on Reddit. I was curious. Are all the people also frustrated with this challenge? And it just, that's all I saw. Lowest common multiplier, and I stopped already looking. It's like, huh. And that's the solution. And if I would have kept digging with my input data, I would have seen that. Because I threw it out and I said, I don't think that's possible. A mathematical solution, I don't think that's possible. Because I assumed this network to be so complicated. That this Z can reach any of the other Zs in any of these phases. I assumed it to be super complicated. But you will see in just a second that it isn't. Okay, so I'm going to now show you print gcur and zmap. That's the two things that I've generated. And actually, I want to say I have my handy little thing pprint that helps me. So the ghost current and the zmap, because I'm trying to find all the z's, right? It's a lot shorter than you would expect, and I have 3 things in here. And let's start with the G currents. It has all of the different starting locations of A, and in them I only save one thing: how many steps does it take to get to the next Z, and which one is it? So this is the next step. What I didn't save is this last digit. I should have saved that straight away. Now I have it, but I didn't do that straight away. Which is, okay, this is how many steps it takes. What offset is it? And as you can see, all of them are at offset 0. Oh. So AAA is going to reach ZZZ after so many steps, but at offset 0. Which means in our Z map, only offset 0 is important. Like I said at the very beginning, I had calculated it for all the different offsets. Now, ZZZ, if we are at offset 0, that is how many steps it takes to get to ZZZ, which will also lead to offset 0. Also, this number is identical to this number. In other words, what we really have is not a complicated network of stuff. Very sorry for this. Trying to manage here my little drawing keyboard. What I actually have is the Z going through a whole bunch of points back to itself. And these points, if you actually look, some people did visualizations. They go in zigzag patterns. Okay, that is kind of the thing that seems to be happening. That is yes, it's branching off, but it's coming straight back to one another, or at least close. So there are these loops. So X or A, B, Z does one loop. Z, Z, Z does another loop. X, Y, Z does another loop, and so on. They never crisscross one another. They have their own individual loops where they go back to themselves. And the face is consistent. I was worried about the face because if they would not be at one another in the same face, if I now jumped again, I would miss potential points I was worried about. But this has been simplified so much. And this is the thing that I have learned about, and this is my takeaway point from this challenge, is the input instructions are not enough. Actually, they actually were tiny bit misleading because here it's actually offset. As you can see, the LLR, notice when I'm going to be at A. First, I'm going to be at A at 0. So I'm going to go left. So I'm going to go to B. Now I'm going to go left again. Oh, I'm at A now. Now I'm at A at stage 2 after the second one. Okay, so I'm going to go right. Okay, I'm going to go back left. So now I'm at 1 at A. And then I'm going to go left. And then I'm going to go right. So it's actually, here the offset is actually misleading because you do jump back and forth between the offsets. So that was tiny bit taking me away from it. But the thing that I'm absolutely learning is, if you don't have a solution, tinker and look at the input. The input is part of your solve path because you don't need a generic solution like I did, even though I really love having generic solutions. And for coding interviews, that's important. But for the coding challenge, for admin of code, your input belongs to your instructions. They go together. You're solving for this specific case. And that is what's going on. So how did I now have a solution? I know it is something about lowest common multiplier. And the point about lowest common multiplier really is all of these are now frequently going in the same phase, which means I just need the lowest common multiplier from all of those rings, and because that is the first time that they all end up at a Z at the same time, and that's really it. I've just used the math LCM. I want to encourage you, and I might do it myself just to practice. Implement an LCM for yourself. You might need to think about greatest common divisor if you only have 2. If you only have 2, greatest common divisor is a helpful solution. If you have multiple values that you want to take the lowest common multiplier for, you might want to think of primal dissection, if that's the right word. But yeah, dissecting into primal parts, prime numbers essentially, and because every number can be represented by a unique representation of primes. So 8, for example, is 2 times 2 times 2, 2 to the power of 3, for example. And that is possible with any number. So, and then with that, you can manipulate it to find the lowest common multiplier. So that's what I want to suggest. So I want to show you really quickly what I have done, what my idea, like how I implemented the whole shortening the paths, and then what my general solution attempt was. And then you already have the solution now, which is just the lowest common multiplier. So what have I done? This part here is identical. I'm just taking the inputs. Now this part here, this for loop, is supposed to shorten it all. Okay, so I'm essentially going from an A or a Z, and I'm looking, hey, when's the next time I see a Z or an A? I did that originally for all phases or for all offsets of the phase, and that's why I called it a phase map, even though I'm not using phase map anymore. So I can take this out. So I'm going 4D in directions for each of them. If the last character is either Z or an A, I want to process it. If not, I skip it. I have a scene set. Then I say current is now D, whichever the current one is. Cool. I guess I could have just said D, but that should I do actually at parts as well. I don't know. Then our step for this particular one is right now 0. And here I'm doing the same thing again. I'm rotating around. And we can shorten this again. Temp instructions is just a copy here. And I need a pointer. Temp pointer is equals to 0. While true, be careful with your while true loops. I needed a while do loop instead of a do while loop. So I have while and then I have my do thing back here. So so I take the top one. Actually, I don't take it. I just say temp pointer. Okay, so now I have my current temp instruction. And I check, hey, where would it go? So I'm doing the same thing again. Now I'm also, it helped me. I don't know if it still helps me after taking away all of the shortenings. I think it does. If I have seen this node already, then I want to break and say, hey, -1. This does not apply anymore. This helped me because some of the paths actually didn't lead to a Z, which should have been a warning hint for me as well. Like, if I reached this Z at a phase offset of 53, for example, it actually never got to a new Z. Oh, sorry. So I needed to check, hey, am I now in a new loop, in a smaller loop? And that is what this was for. I don't need this anymore. So this whole scene thing is not needed anymore because I'm not dealing with these offsets anymore. And this here is just my, and then I say step +1. This is essentially just what we had up here. It's the same as here, what we're doing here, just for each D in directions. We're already pre-computing them. Here, I don't want to say this anymore. I just want to say pointer plus equal 1. Also, my pointer, I need to say modulo length of temp instructions. And I don't need any of this. Just say temp pointer plus equals 1. Now my break condition is if the last character of my current is now a Z, then it means I found it, I can break it, and then I can save it either into the Z map or into my ghost currents with those exact things. I don't need the offsets, that was just for demonstrations, so I can take this away. So the steps and current, that's what it is. Really, I don't need the A either anymore, because I know now that they are all identical as the loop itself. That is just because of what it all is, which means ghost current is not needed either anymore. Okay, and this should still give me my valid solution. Boom. Awesome. Preprint is gone. Now, this, so I'm really just pre-calculating, like I've done up here, I'm just pre-calculating it for every single D. And I did it, like I said originally, also for every single offset for the phases. That was cool, that was easy. That was not too tough. But then I needed my general solution. And I'll delete that now as well, because I won't need that anymore. Because that's where I actually needed this stuff for my general solution. Now I don't need that anymore. The pre-computing only helped me with those max steps. And then I just put them into my lowest common multiplier. How does it look here? I have my Z map. So I say 4x Z map. And then I want to I take the very first, the steps. That's all I'm doing. Z map of x, so that's the address, and then 0 is the steps. Put them all into a list. This comprehension again, and I'm just unfolding them, whatever the correct term in Python is. right? I'm just spreading them out. And that's it. And then it calculates the lowest common multiplier. That's how easy the solution is. Should have not been much more difficult than part 1 because I'm just doing it now multiple times. But that's it. What was my general solution? My general solution was while not in sync, and not in sync means going through all of the different states, okay, and check, hey, if I don't have a first one yet, okay, well, it's none, then first is the current state, and otherwise I compare the first to each other state. If any of them are not the same, then I return false. Boom. That's all it is. Really, the point here is, are we all at the same step? If we're all at the same step, that means that I know that we're currently all at a Z with the current steps. And that would have been it. With the same amount of steps. If that's not the case, I only want to increase the smallest one. That was the idea. So steps is 0. Smallest is currently none, while not in sync with current, which I know is not the case because current would have been at that moment, would have been all of our current locations, of our Z locations, and the steps that it took us to reach them from A. That was my idea. They're all gonna be not in sync, otherwise there would have been a trivial solution. And then I'm gonna say, hey, the smallest is none. I go through my currents once, hey, and then I compare them all and say, hey, which one is the smallest? And put the smallest in there. Smallest value is then whichever node we are at, and then I only do that one. I only take with the Z map here, and then the face I need to divide by the face length, so that I then can create the new value, smallest value, and then current of smallest is now our new smallest value. Steps is now new value and the old value of our smallest value, just to keep track of what the smallest value would have been. And then we repeat. So what that would have done, it would have had a list of all the ones of all the current locations. And I could have done all of them except the biggest one, but that would have been a similar solution. So every time I go in this for loop, it takes the bottom one and bumps it up, either still underneath or to the same or above. And it keeps bumping up the bottom one. And generally they keep coming up and coming up until hopefully eventually the top one is here, we bump one up and it hits the same one. Then we bump the next bottom up and hits the same one. Until we have hit the next bottom up and they all hit the same one. And then we know, hey, we have all of them have the same amount of steps, which means we can return the steps, and that would have been our general solution. Obviously, this is not our solution anymore. So, this was a headache of a puzzle. I was proud with my general approach with the path shortening. It was still not good enough. And I was a little bit frustrated initially, not gonna lie, but again, I take a valuable lesson out of it, and I want to stay positive. Yeah, I'm gonna try my hardest to not be talking like down or talking like bad about things. I want to be honest. Like, I felt frustration, but I've learned that that's what admin of code is about, because it is a very specific instruction and very specific input. You need to play detective for a tiny bit, and it's a puzzle game. Okay, so part of the puzzle is this input, and I need to dissect it. If I don't come to the solution with a generic algorithm, hey, dissect it until you find some kind of weakest link. That's the thing. These puzzles are not supposed to be done by super machines. These are supposed to be able to be done by a common computer, which means there is a solution out there that even I can solve. I hope this was interesting. I hope this was helpful. If you want to see the 2-hour video, go check it out. It's now 10:20, almost, or 40 minutes before the next coding challenge for me, but that's for day 10. This was day 8. I still need to explain and record day 9, which I couldn't do last night either because I had to get up really early. So I was sleeping at that time. So yes, when I record the next video, so y'all see me in this for the next few videos, which is fine. I hope you have a good day, and I see you soon. Bye. Oh, no. Auf Wiedersehen.